In previous math classes, you have learned to solve quadratic equations by the factoring method. The quadratic equations are trinomials, and usually we have an x squared term, an x, a constant, and of course to be in standard form we want it to equal to 0 so we can start factoring. And so here we of course would factor this. We would say maybe what multiplies to get 4 and what multiplies to get 3 and manipulate the numbers where we would get a negative 8. I think this will work because that's 4x squared. Let's see, that's negative 3 and negative 2, which is negative 8, and of course that's positive 3. Then after we factor, we set each factor equal to 0, and then of course solve for x, and we get two solutions. Let's just try that again. Here we would factor what multiplies to get 5, what multiplies to get 4, either 2 and 2 or 4 and 1. And so checking that of course is 5x squared. That's negative 20 plus 1 is negative 19x, and that's negative 4. And again, after we factor, we would set each factor equal to 0 and solve for x. Again, getting two solutions. But reviewing what a quadratic is in general form is that ax squared plus bx plus c. Before we go any further, I want you to recall that that exponent on that middle x is really a 1. And so we have a relationship between this exponent and that exponent. And what is that relationship? Well, this one is twice that one. So if I take this one and multiply by 2, I get that exponent. Keep that in mind as we proceed, because now we're going to look at equations that kind of look like a quadratic, but they have different exponents. So this looks very much like the problem we just worked, except the exponents are different. This one also looks like the second problem we worked, but again, the exponents are different. And here, oh goodness, we have negative exponents. But again, what is the same in all of this pattern? If you take this middle exponent and multiply it by 2, you get that one. This one by 2, that one times 2. And so math is a lot about patterns, what works for one. If it has a similar pattern, we might try that same process. So how could we factor this one? Well, we just saw when we had 4x squared minus 8x plus 3, we factored it like that. So could we use that same factoring technique but just change the exponents just a little bit? Well, I think so. So I'm going to try 2 and 2 because I know that multiplies to 4 just like this did. But how about x squared times x squared? And then minus 1 minus 3 equal to 0. If I check that out, again multiplying those together I get 4x squared, but when I multiply that together I get my negative 6x squared. That's negative 2x squared, which is going to get me that middle term. And of course negative 1 times negative 3 is positive 3. So look at what I did. I used the same factoring technique that I did for the quadratic for this imposter, if you will. And instead of x that matches that middle term, I used x squared that matches that middle term. So we're going to proceed. What did we do after we factored? We set each factor equal to 0. And we solved for x, but we don't have x quite yet, so let's get x squared by itself. And then remember, how do we go from x squared to x? We're going to take the square root of both sides. We're going to remember we have a plus or minus sign. The square root of 1 is 1 over the square root of 2. And then one more step. Let's rationalize that denominator. Let's get rid of that square root in the denominator. So we have plus or minus 1 times the square root of 2 over 2. Going to do the same thing here. Ooh, what did I leave out? My plus or minus sign. So I have plus or minus the square root of 6 over 2. So we no longer have 2 answers, but we have 4 solutions. All right, let's look at number 2. How did we factor this quadratic? Look at your notes. We did that on example 2. We factored it like that. So I'm going to use that same factoring technique, but what am I going to change? I'm going to change those exponents. So since those matched, I need to make that match. So I'm going to have 5x to the 1/3 times x to the 1/3. But I'm going to keep everything the same as I did for that quadratic. So setting them equal to 0, solving for my x to the 1/3, and then I have to remember what undoes that 1/3 power, which is the same as the cube root. I need to raise it to the third power. I need to cube both sides. Okay, remember our laws of exponents. If I multiply those together, that is 1. So I have x to the first power. I'm going to cube it. So that's 1 over 125. And I believe 4 cubed is 64. So again, using those same techniques that I learned how to factor, but just tweaking those exponents. So again, I'm going to think, how would I factor the corresponding quadratic? Well, I'm going to give you a minute. Why don't you pause and see if you can factor that? Is that how you factored it? Okay, so let's leave it like that, but now let's come back up to this equation. And what would you change? You're going to change the exponent. So instead of x, again, now we're going to factor that. We're going to change that to the negative 1 power. So I'm going to solve, I'm going to set both of these equal to 0. I'm going to solve for x to the negative 1. And then I have to remember, how do I get rid of that x to the negative 1? Well, there's a couple of different methods. First of all, remember that x to the negative 1 is 1 over x. So we could rewrite this as 1 over x. That might be one way to do it, but I still need to solve for x. Again, you have a couple of choices. You could cross multiply and divide. I kind of like to just do this really not quite mathematical word. I like to flip both sides, which means really take the reciprocal of both sides. So 1 over x, if I take the reciprocal, that's x over 1, but I have to take the reciprocal of that side as well. And so the reciprocal of 1 over 3 is 3. Now some of you math people may be cringing, and that's okay. Another way to think about this is I could raise each side to the negative 1 power, because negative 1 times negative 1 is positive 1. And then what does a negative 1 power do to make it positive? It takes the reciprocal. So we're there either way. All right, so again, I'm looking at this quadratic, but I'm going to, well, not quite quadratic, but if I make it into a quadratic, and I say, how would I factor that? Again, why don't you pause the video and practice your factoring skills. Okay, so we checked that, and that does factor that, but now, how do we factor that? All we have to do is match those exponents to that middle term. So I need that 1/4. Convince yourself that 1/4 times 2 over 1 is indeed 1/2. That's that relationship between the quadratic and what I call the quadratic wannabes. So I'm going to set these both equal to 0 to solve. And then 1/4 power, I need to raise each side to the 4th power, just using the reciprocal of those exponents. So that's x. And then I think 4 to the 4th power is 256. And 2 to the 4th power is 16. So that's how you can use your factoring skills to solve quadratic wannabes.